All right, so picture this. You're in the zone, totally locked into a video game.
Okay, yeah, I see that.
You're exploring this massive open world, and it feels so real you almost forget it's not.
I've been there for sure.
But what if I told you that same tech, the stuff that makes those digital worlds so immersive, is being used to create virtual battlefields right now?
It does sound kind of wild when you put it like that, but yeah, it's changing how militaries train and plan their strategies.
That's what we're going to dig into today.
Cool.
How software that powers games, like even ones you've probably heard of, Pokemon Go, Cities, Skylines.
Oh, wow, really?
Yeah, just being used to design these crazy, realistic, simulated war zones.
That's
We're
incredible.
going behind the scenes of this tech, breaking down a research paper called Research on Application of Unity3D in Virtual Battlefield Environment.
Catchy title.
Right. It's by Jian Wu and their team.
Okay.
And they don't just talk theory, they actually built a virtual battlefield.
Wow, impressive. What, like a whole war zone?
A whole airport,
No way. That's ambitious.
to show how powerful this approach can be.
I'm intrigued, that's for sure.
So the paper, it starts by explaining what a virtual battlefield even is,
Okay.
defining it as like a key part of something called combat simulation.
Right, which makes sense. Gotta start with the basics.
And I think that's where we should probably start too.
Absolutely. So, think about it. Traditionally, military training meant a lot of real-world exercises.
Yeah, makes sense.
And those exercises, they get expensive. We're talking fuel, equipment, logistics, the whole 9 yards.
Oh, for sure. It adds up quick.
Not to mention, it can be dangerous.
Right. Very high stakes.
Exactly. But virtual battlefields, they let soldiers train for all kinds of situations, from basic combat to, really complex scenarios without any of that risk.
It's like a high-tech version of those toy soldier battles we did as kids.
Ah, yes.
Except this time, well, the stakes are a bit higher.
Just a little. And it goes way beyond just learning how to fire a weapon.
Yeah, I was just thinking, it can't be as simple as that.
Not at all. The paper talks about how these simulations can be used for everything. I mean, everything. From planning missions to testing out brand new tactics, new equipment.
Wow, that's incredible.
It really is. And it's all done in this safe, controlled digital space.
That's such a game changer, especially in today's world. So how were these virtual worlds built in the past? Was it literally like grabbing a game off the shelf and being like, all right, let's pretend we're fighting here?
I wish it were that easy. No, the paper outlines two traditional approaches, and honestly, neither of them were a walk in the park.
Oh,
The first one was basically starting from scratch. And I mean scratch.
Right.
Like using these things called graphics APIs, OpenGL, DirectX 3D.
okay. I'm not going to pretend to be a tech whiz here.
It's like building a house brick by literal brick. You have total control, which is great, but it is so time-consuming, very specialized work.
So not exactly a quick process.
Not at all. And you better believe it's expensive.
Yeah, sounds like it. So that's option one. What was the other one?
The other option was to use these pre-built professional simulation platforms.
Okay, so already made.
Right. Faster, definitely, and you had some customization options, but
Yeah.
you were limited by what the platform could do. Think of it like buying a prefabricated house. Faster, sure, you can paint the walls, maybe change the curtain.
But if you want to add a whole other floor,
Good luck with that.
so you were stuck
Hmm.
between a rock and a hard place.
Exactly. And that's where things get really interesting. This is where Unity3D comes in.
Okay, so this is where that whole video game connection comes back.
You got it.
Amazing.
Unity3D, it's this really powerful game development platform, and it's relatively easy to use even for people who aren't like coding masters.
That's important for sure.
And here's the kicker. You don't need a supercomputer to run it.
Wait, so the same software that's making those games is being used for, like, serious military stuff?
Yeah.
That is wild. Is it really that good at creating realistic environments, though?
It really is that versatile. And the paper digs into why it's such a good fit, It all comes down to how Unity3D actually handles the whole process of building these virtual worlds.
Okay, so how does it work?
They break it down into a few steps, and honestly, it's kind of intuitive when you think about it.
Okay, so walk me through it. What are the steps?
First, you've got data acquisition.
Data acquisition, all right.
This is gathering up all the raw materials you need to build this virtual world.
What kind of raw materials are we talking?
Things like satellite images, 3D models of buildings, vehicles, textures, everything you need to make it look realistic.
Oh, wow. So it's like, what, textures to make the buildings look like they're made out of brick or...
Exactly.
That's insane.
It's like an artist setting up their palettes and getting their canvases ready.
Oh, I like that analogy.
It's about laying the groundwork.
So it's like gathering all the building blocks for your digital sandbox. Then what?
Then comes the really cool part, modeling.
Okay, so this is where we actually make it.
This is where you take all those raw materials, those images, models, textures, and you use them to build a detailed 3D replica of the environment you want.
So like that airport example from the paper, they'd have to recreate what, every building, the runways, everything.
Pretty much every little detail.
So you're not just dropping like pre-made assets into a scene, you're actually rebuilding a whole location from the ground up, digitally.
That's exactly it. And that's where Unity 3D's power and accessibility really shine.
Yeah.
It gives developers the tools to craft these really complex virtual spaces with an incredible level of detail that wouldn't have been possible with the older methods.
Okay, so we've got the virtual world looking all nice and pretty.
Right.
But what about the actual functionality? Like, how do things work in this world? How does a tank move? How do weapons fire? You know, that sort of thing.
So now we're getting into the nitty-gritty of it all. This is where function implementation comes in, and it's really the heart of the operation.
Okay, so we're going from the looks to the brains of the operation.
Exactly. This is where code, actual lines of code, makes everything come to life.
So it's not just making it pretty. We're talking about like the physics of this virtual world, right?
Precisely. We need to simulate how everything behaves in this digital environment.
Okay, I'm starting to see how complex this really is.
It's a lot more than meets the eye, that's for sure. Let's take a tank battle, for instance.
Okay, sounds like a good example.
You'd need to program how those tank treads interact with different surfaces. Mud, sand, pavement, each will affect its movement differently. And then there are the weapon systems. How does the turret rotate? How does the cannon fire?
Wow, and I'm guessing the projectile's trajectory and impact, too.
You got it. It's like you need a whole team of physicists and engineers just to make sure this digital world behaves realistically enough for training.
Did the researchers actually get into the specifics of the coding itself in the paper?
They did. They used something called object-oriented programming, which is ideal for this kind of simulation. It basically lets you create these blueprints for different objects and their behaviors.
So like a template for reality almost.
Yeah, kind of. Instead of programming each tank to move individually, you create a tank class with all the properties and actions of a tank. Then you just plop down instances of that tank within your virtual world.
That is so smart and efficient.
Exactly. And they took this approach to a whole other level with that virtual airport they built, which was a pretty gutsy move, if you ask me.
It's one thing to simulate a tank, but a whole airport. That's incredibly ambitious.
It really was. But they chose the airport for a reason. You see, airports are like these super intricate ecosystems.
I've never thought of an airport like that, but it makes sense.
You've got runways, terminals, hangars, all sorts of vehicles and equipment buzzing around, not to mention potentially even civilians.
So many moving parts.
Right, they're like mini cities, each with their own unique set of rules and challenges.
So if you can build a believable and functional airport simulation,
The possibilities for other scenarios are pretty much limitless.
that's amazing.
That's exactly what the paper stresses this technology. It's incredibly adaptable. They proved that Unity 3D can handle a really complex real-world setting, so that means its potential goes way beyond just your typical military uses.
Okay, now I'm really interested. What else could you use this for?
Oh, all sorts of things. Just imagine urban planning with this tech. You could create a virtual model of a city and test out different traffic patterns, see how new buildings or public transportation systems would impact everything.
No kidding. You could design more efficient, livable cities.
Exactly. Or what about disaster preparedness? You could simulate earthquakes, hurricanes, train first responders in a safe environment before they have to deal with the real deal.
That's incredible. It's like a whole new world of possibilities.
And it's not even a one-way street. Just as we're taking this gaming tech for serious purposes, all these advancements are feeding back into the gaming world, making those experiences even more immersive.
It's like a feedback loop of innovation.
Exactly.
Okay, so we've talked about the present, but what about the future? Where do virtual battlefields go from here? What's next?
Well, the paper is very optimistic about the future of Unity 3D for developing these systems, but what really excites me is how it'll all evolve with things like artificial intelligence, machine learning, all of that.
Okay, now we're really stepping into the future. Tell me more.
Just imagine simulations populated with super realistic AI-controlled entities. Think about going up against opponents that can learn your strategies, adapt to them.
So they'd get smarter as you play against them.
Exactly. They could even surprise you, force you to think outside the box, talk about challenging.
That would be incredible for military training. Always having to stay one step ahead.
Right. And that's just the beginning.
Well,
Who knows what amazing breakthroughs are on the horizon with this technology?
it really makes you think, about how far we've come and what's next. This is some serious next level stuff.
It really is.
But like any powerful tool, we have to be careful, right? Especially as these virtual battlefields become even more, I don't know, intense.
Absolutely. I mean, think about it. These simulations are becoming so lifelike, and now we're adding in AI.
Right.
We have to be sure we're developing and using all of this responsibly. It's a huge conversation.
Definitely something to keep in mind, especially since, like you said earlier, this isn't sci-fi anymore. It's the world we live in.
It is. And that actually brings me to my final thought for you today.
Okay, I'm listening.
As we've seen, right, the lines between virtual and real, they're getting blurry.
For sure.
This whole fusion of gaming tech and real world stuff, it's only going to get bigger.
Totally.
So as you go about your day, see a new video game, hear about some new tech breakthrough.
Yeah.
Think about the connections, the stuff happening behind the scenes.
Ask questions.
Exactly. Ask yourself, what else could this be used for? What impact could it have? You might be surprised.
I probably would be. This is definitely giving me a lot to think about.
It's fascinating stuff.
Well, on that note, I think we'll wrap up our deep dive into virtual battlefields and, of course, the surprising role of gaming technology.
It's been great exploring all of this with you.
Until next time, everyone, stay curious.